So, hello and welcome to my talk about the limits of vibe coding, AI hype, and the future of real software engineering. So, before we get started, I guess a lot of you are software engineers. I think you can tone down the microphone just a bit. So, just wanted to hear first, who of you is like working as a software developer or software engineer? Okay, so few. And the others are working at least in IT, I guess. Okay, so my name is Gläser. I work as a senior Azure cloud architect for Nordcloud, which is going to cease to exist in 2 days from now, and then just going to be called IBM. So that's why I dashed it through. And so at Nordcloud, I work on cloud native systems, and code there has to survive architecture decisions. So if I make bullshit, it still has to survive that. There is shitloads of security and compliance stuff that comes in place with my company. There is production incidents, there's long-term maintainability, and with long-term maintainability in a company like mine who does cloud consulting, you have to keep in mind that the teams change over time and still the code has to be maintained. And also, we usually work for customers, and so there's always code handovers and responsibilities. And I started writing software as a child, like QBasic, in case any one of you still knows that. I started working with that. And as a serious software developer, I started in around 2008. So quite a few years under my belt. Just as a disclosure, Nordcloud sponsored this talk in the way that they paid for travel and expenses, but they did not have a say on my slides. So when we're talking about AI in this talk, I just wanted to make clear that what I'm talking about is generative AI and LLMs. There's obviously other, let's say, kinds of AI that are in place, but this talk mostly focuses on LLMs and generative AI, which is, I think, the most hyped topic at the moment. And I wanted to give my personal definition of vibe coding. Vibe coding is writing software primarily by prompting AI until something appears to work. So, I wanted to start with a question. This is sort of like a typical vibe coding question. Could you please build me an app in 10 minutes? And then the question is, why could this fail in production? Anyone wants to answer? Okay, please. Exactly, yeah. So this is actually key takeaway one. Production systems usually don't fail at compilation. They fail somewhere later. They fail because a secret was replaced, for instance, or because someone did not take into account some strange formatting errors with like a legacy XML document or whatever. But the question that came for me when I prepared this talk was, so if AI writes the code, what's left for the developer? And I guess that's a question that's like in the mind of a lot of people these days, because it's quite clear that AI is changing the way we work as software developers. And it leads to a more fundamental question. So if AI is taking over more and more of the implementation work, what remains the responsibility of the software engineer? And I wanted to bring up this slide. I don't know if you know this theory of the silver bullet, but it's sort of like a typical thing in IT that a new thing comes out. We could give cloud computing as an example. We could give object-oriented programming, REST-style interfaces, or if you go really old, introduction of personal computers or whatever. And it always was the same thing. You said, this is being introduced and this solves all problems that are out there. And it effectively promises the same thing, that complexity disappears And the thing is that AI can generate working code in seconds, but does the code survive in production? And this leads me to this hype question. So I just I guess you know these Google graphs. So this is just some hype topics from the past. I took a topic in for reference that's not a hype topic, world peace, because that's definitely not a hype topic at the moment. But so you see all these topics, for instance, cloud computing has a peak and then goes down, and big data obviously had a peak a bit later than cloud computing. But so at one point this was always hyped. If you take AI in comparison, world peace seems a flat line. In the other ones it's at least has some spikes, but with AI it's a flat line. So I say AI is not a hype topic, it's a mega hype topic. And I want to say that hype doesn't mean it's useless, it just means that the expectations are way ahead of like implementation. And way ahead of maturity. So if we look into this hype cycle, and I wanted to know, does any one of you know this Gartner hype cycle curve? Yeah. Okay, so we start with, let's say, these AI coding assistants that started to appear, let's say, a while back. And then at the moment, I think we are at this peak of inflated expectations that AI will totally replace developers. All developers will go out of jobs in a few years. And my assumption is there will be this drought of disillusionment coming, because at one point people will start realizing, oh shit, there's now shitloads of AI generated code out there, but it's not working properly. And this is like where the disillusionment will come in. And just an example, I talked to a cousin of mine the other day. He's not a software developer, he's a policeman. And he said, yeah, well, I used vibe coding to then connect my my home NAS setup with Freema. Just to get notified if I should make a backup or not. It seems to work, but then it tells you a bit about the extent of, let's say, vibe coding these days. If someone who has never dealt with programming at all starts to do his own programs. But you can expect that some of these programs will eventually land in a production system, because people will say, well, they're useful, so they will be continue to be used, and then there's problems because nobody takes ownership for them long term. And then my expectation after that drought of disillusionment is that at one point there will be like a realistic assessment of how much you can do with AI and how much you cannot do with AI and what tasks you still need. And I also wanted to bring in one thing that I think software engineers are already really needed for, and this is like a pretty current topic, because just like a week or two back, Microsoft and all the others drastically increased token pricing. And then, for instance, in my company, people started screaming, I cannot use Copilot anymore, because now the tokens are all used up in one day. Yeah, so I guess you experienced that yourself. And so the thing is, if you use LLMs at a scale, it becomes really costly. And now that people are hooked up to it, companies are increasing the prices more and more. And in my opinion, that means that you will start to need to combine models. For instance, you use local models as well for preparing the requests. You start using simpler models. You start to use, let's say, more complex models that are costlier for complex queries, but you can start using simpler models. And that's something that a software engineer, I think, can do better than a person that's not trained in the layman, to say it this way. yeah. And I think I'm not that late in my talk. Okay, so just wanted to say this is something where software engineers are asked for, and this will be a question that will come up more and more, because cost is a thing that was always part of being a professional software developer, because the question, how much is it going to cost, like now, how much time and effort do you need to spend it to create it, how much time and cost will it need like over time, is a question that's like typically asked in the beginning and during a project. And I want to just give a few examples of what AI, in my opinion, already does quite well. Obviously, there's boilerplate generation, and for all of you who were in software engineering a bit longer, boilerplate code and like scaffolding of code is something that was there before AI already. I think it's just a bit more fine-tuned now. Test scaffolding is something where AI is also really good at already. Asking questions like, could you please create some tests for my code? What kind of tests are needed? Could you please generate sample data, which is really useful, especially like if you're working in fields like finance, where there's like the prerequisite of using synthesized data instead of real test data, because the typical use case that I know from a lot of companies is that they copy the production system over and use that for test data. And with all these legal issues that came into place more and more the last years, just being able to generate realistic test data from AI, which is not connected to any real customers, is a really useful use case already. Then there is the question of documentation support. And there is actually two use cases with documentation that came into my mind. There is creating documentation for code that you either generated or created yourself. And the other thing is you can compare the existing code and the existing documentation against each other and kind of find out, oh, what's missing there. And as documentation is usually not equal to the code that's out there, that I find is a really useful case. Then there is the topic of API exploration, there is rapid prototyping, and there is one thing that I want to say which is good about AI and vibe coding and so on, because AI makes programming a bit cheaper, because it makes it faster. Projects that were not possible before, you can do them now because they're economically possible. So, for instance, I met a freelancer a while back and he said, it's awesome. In the past, I was only able to offer the clients, let's say, a project for $500,000. Now I can give them the same project outcome for 100,000. And this way the client is actually able to purchase it. But it breaks down at some points. So, in my opinion, one of the things where vibe coding and AI is not really good at is at domain knowledge. So if you work in an existing field, LLMs specifically, they have only very general knowledge of the field you're working in. So, but usually with the context you're working in, it's specialized, it's not embedded in LLMs. So you can somehow embed it by, for instance, by using MCP servers, but still it's going to lag behind a bit. So you need to know what's the actual requirements, you need to understand the business to define if what comes out of it is actually a useful result. Then the other thing is you need to specify better. Architecture design is becoming more and more important, because if you don't specify it properly, AI will just generate as is without the specifications. And then if you, for instance, if you don't specify it should be programmed in C#, Python code might come out of it. There is the problem of root cause debugging. I just say that AI is really useful for finding bugs and errors, but for difficult cases and if the data sources are not connected, sometimes you need to know what can be the use case, what can be the causes of problems. Performance optimization is also not necessarily something where I see AI as like the best tool to use, because AI tends to generate too much code. So if you use AI, it tends to generate a lot code. It tends to generate code that's like distributed amongst too many classes, and it tends to generate, let's say, a lot of error handling that I, as a software engineer, say not necessarily needed in this specific backend program, because all this exception handling that's built in there automatically, I already catched it to levels earlier by doing input validation already in the front end, for instance. Then there is the question of long-term maintainability. And then AI does not take ownership, a person and the team does. And system ownership in general is also something that an AI cannot take over. It needs to be owned by a group of people, and this group of people also needs to take the decision: do we want to keep it, or do we want to replace it? Do we want to sunset it? All these kind of decisions, and that's all the business decisions. So for instance, a while back, I migrated a cloud, migrated a bank into a cloud, and we did a lot of these decisions saying we don't want to use these applications anymore, we are going to replace them with different ones. AI cannot really do these decisions for you. Someone needs to take ownership for them. Someone needs to take responsibility for them. And so this leads me to the question of this talk, where responsibility moves eventually. And I think I already teased it quite a bit. So I see code writing as a skill. It's still relevant, but less so than in the past. Syntax recall, I mean, was already less and less relevant before AI, because there were like good syntax tools to fulfill code for you. Boilerplate code, definitely. I mean, there's nothing easier to start a program than by typing into an AI, I want to start XY project, could you please generate a setup for me? And basic CRUD requests, I think, like get XY from user database. This is something that also AI can do really, really well already. What I think people should invest time in is in these high-value engineering skills. And then for those of you who studied computer science in university or in a University of Applied Sciences or somewhere else, or like did some vocational training, this was always part of the stuff that you needed to learn. But usually you just hacked away, or I mean, myself as well. I love coding, I just love writing code, but I just know this is becoming less relevant. So I think you need to do the architecture better. You should focus on specification. And then with AI, one thing comes into play that you do the specification first design more and more. If you think about writing prompts, what used to be taught in university was you write the specifications first completely, and then as a result, out of writing these specifications, you create software. And usually, in reality, it was not done this way, but with AI, it makes a lot of sense to do it this way. Obviously, you need to understand the domain and the context of what you're working in. I think collaboration and ownership. I mean, communication is sort of a thing. It's not taught enough in university, but for everyone who worked in IT a while, he knows. Okay. So. Yeah, please try that again later. So I would say communication with stakeholders, understanding actual requirements. That's something AI also cannot do because it involves talking to people, it involves understanding problems, and then if you talk to stakeholders often enough, often they have only a very fuzzy picture of what they really want. So like from their, let's say, idea to actually come to a specification of what needs to be implemented, that's something I think you shouldn't do purely with an AI. You should use, let's say, some sort of judgment as well. And then obviously at the end there is this validation step. If you write using, or if you create software using AI, at one point you need to validate it if it's correct. And I think at least some validation should be done by humans as well. And then I just give an example here. For instance, Microsoft, they started creating a lot of their .NET framework using purely AI. As a result, the number of bugs that came in also increased quite massively. So if you look into the bug reports for .NET framework, for example, and it's mostly public in GitHub, you see that like the amount of publicly known really bad bugs increased quite a bit lately. And I want to introduce one concept here. So I guess some of you in this room may know Martin Fowler. Okay, so I think it was 2014 where he introduced this concept of sacrificial architecture design, where he said effectively creating source code becomes faster and cheaper. And we talk about 2014 here, that was before AI. So effectively source code becomes dispensable. What's becoming more and more relevant, or what's becoming more relevant in comparison to that, is the architecture and the design and the specifications. So if you bring that to an extreme, you could say, okay, I just recreate the code every time I need a new specification. I just increase the specification and the code gets generated from scratch all the time. A bit problematic to do it in this extreme extent because it uses a lot of tokens. And I think for those that were in this room for the last talk, this AI as a team concept I think was already introduced there a bit. And I just want to say, if you use AI properly and not just with, let's say, one agent, but with several agents, you give each agent like a different role. And you in the middle sit there as a developer. And this shifts your role quite a bit from a developer who typed code himself to a person who orchestrates the development and assigns tasks to different specialized AI agents, with the idea of each agent doing that he can do best because he has a limited focus. Similar to like what you do in normal software development these days anyway, that you have a tester, you have someone who writes documentation, you have someone who does research, you have a reviewer, and you have someone who does refactoring. So, one of the stances of my talk is that I say, if you use AI right and you know your skills, you get a better quality out of it, but you still need to do it properly. So if you are like my cousin, the police officer, you don't know engineering, so what comes out of it is properly a code that has a lot of technical depth. It's inconsistent because you don't know which language you should use for that. And I'm just giving an example here. If you don't know the right language, you're using, let's say, a floating point system for banking application. And you introduce a lot of hidden complexity that if you knew your stuff, you would reduce it automatically by saying, this is shitty design, please do it differently. So if you know your shit, you're creating better systems, you have a better architecture, and in the end, you can become a better engineer. And then my key takeaway here is that AI, if you use it correctly, it doesn't replace expertise. It uses your expertise to make better code. And this leads me to my conclusion. So if you use AI correctly, it doesn't remove complexity, it moves it. Your job moves from writing code to orchestrating AI agents to doing more architecture and design work and use your skills where they're most valuable for yourself if you're a freelancer, or for your company if you're an employed person. What I said in the beginning, production system, they don't usually fail at compilation. And so just there is this important thing, working code doesn't mean working system. And I think what's pretty clear is that the value of engineering, where you need to put your time and effort in, it's shifting, and AI turns development more into an orchestration job. At that time, I would like to thank the sponsors of this conference, and if there's any questions, please go ahead. And if there's not questions at the moment, feel free, there's this barcode that I was asked to add. Feel free to give feedback on this barcode, or if you want to get in touch with me personally, feel free to write me a message or send me your contact request.